aggregation becomes even more useful when you form groups of rows. Rows in a table can be grouped using a group by clause. Then when you aggregate, instead of putting all of the rows into one number, you perform aggregation on each group. Okay, so you can write select something from table. You can still have a where clause and stuff like that. But now we have something new, group by. Group by gives you some expression, and then having tells you which groups to keep. The number of groups is the number of unique values of this group by expression. So for example, if I write group by legs in the animals table, there are two different unique values, 4 and 2, and so we'll get two different groups. This says show us the legs for that group and the max weight for that group for each of the groups. Here are the four-legged beasts. Here are the two-legged beasts. Each of those is a group, and so each of those corresponds to one row in the output. It's okay to write legs here without aggregating because we grouped by legs, and so we know that in each row of the output there will be only one legs value for all the rows that were grouped together, and so we can write that legs value here as reference. And this says that the heaviest beast with 4 legs was 20, and the heaviest beast with 2 legs was 12,000. The having expression, which is optional, selects which groups you want to keep in the output. Maybe you don't want all the groups. A having clause filters the set of groups that are aggregated. For example, we could group by any expression we want, like weight divided by legs. This will perform integer or floor division and give us an integer that might be different for different animals. So here we compute weight divided by legs and we get 5. For this one, 2. For this one, 2. For this one, 3. For this one, 5. For this one, 6,000. Now, some of these values are repeated. There's 2 2s and there's 2 5s. Having count star greater than 1 performs an aggregation for each group to count how many rows are in that group, and then only keeps the group in the output if the number of rows is bigger than 1. So what happens here is that we end up with 2 rows in the output, even though we got 1, 2, 3, 4 different values for the group by expression, because we only kept this group and this group, and we threw away this group and this group because they didn't pass this condition. What's the difference between where and having? Where is about whether to keep an individual row from the input. Having is about whether to keep a whole group. In a where expression, you can't aggregate because it's about just one row. But in a having expression, you can aggregate because you're asking a property of the whole group. Here's an example. I want to group movies per decade. Create a table with columns decade and movies that contains one row for each decade in which a movie was released and the number of the movie among the 1,000 in the data set that were released in that decade. We're going to use count again to get the number of rows that have that decade. And how do we get the decade anyway? Well, here's a hint. When you divide an integer by another one, then SQL performs floor division. So if I divide 43 by 10, I get 4. That's useful for turning the year value, like 1922, into a decade value, like 1920. I'll let you think about it. I recommend pausing the video, and then we'll take a look at the answer in 3, 2, 1. Here's how you compute the decade from the year. Divide by 10, that gets rid of the last digit, then multiply it by 10 to put a 0 there. That'll get us from 1922 to 1920. That's our decade. The number of rows that had that decade value is count star. We'll call that movies. We're using rows from the titles table, and we're grouping by the decade. We could also rewrite this expression here, but that would be a lot of typing, it's much better to use the name of the value that we've already computed.